All right. So section 210, last section of the unit. Woohoo! Derivatives of tangent, cotangent, secant, and cosecant. So far you learned sine and cosine. We did that back a couple sections ago. But they reminded you again. The derivative of sine is cosine. Derivative of cosine is negative sine. Here's the new ones for the day. So on your cards and on your notes, the derivative of tangent is secant squared x. The derivative of cotangent is negative cosecant squared x. Derivative of secant is secant tangent. And derivative of cosecant is negative cosecant cotangent. So I'm going to give you a couple minutes to fill those in on the notes, but also fill them in on your card or whatever you've got going on for your reference sheet. You know what else you want today too while you're digging for stuff? You want that, remember the trig chart that we made? And I think you all have that. It's the one with the unit circle and all the different trig values. If you have that chart still, you want to have that handy. Do you know the one I'm talking about? It might have been on a different colored piece of paper. We are missing a bunch of peeps that fell off here. I feel like my classroom kids have...
Miss Wenner.
Yeah.
What when you're absent? Like, do you get in trouble?
For who? For you or for me?
For me.
If you, like for today that you should be technically in the classroom, but you're home?
No, like, on Friday, I can't go to my Zooms. Like, is Gateway going to be mad at me?
They're not going to be mad at you. Worst case scenario, they're going to mark you absent.
Okay.
And that's, even at that, it's, right now, yeah, I wouldn't worry about it. If it's something, if you have an important class, you might want to just shoot an email to the teachers saying, I'm not going to be able to be at your Zoom meeting today. Let me know what I missed. But if it's not, if you don't care, then that's okay too. Some classes are ones you may not care what they're doing. Okay. Did you get time enough? Are we good? I can move on? So here's, let me do it. Let me do the problem with you. All right, so here's the first one. The first one is find the derivative of sine of x tangent of x, right? And he says, here's some common struggles for this section. Memorizing all the rules. Well, yes, but you've got a note card that's going to help you. The unit circle values. Hard to remember how that unit circle works. You've got a chart that you're going to be able to use, right? So you don't have to worry about that either. Simplifying and manipulating the trig expressions. That's the kind of stuff that you need to go back and remember our pre-calc rules. Things like the fact that tangent, I'll put it over here, tangent is sine over cosine. Do you remember that from back in the day when we were pre-calcing together? Those types of things. How to simplify these trig expressions. Sometimes maybe you might want to change a tangent into sine over cosine. Sometimes you might want to change sine over cosine into a tangent. Depends on the problem. So manipulating trig expressions is something you need to think of. And then the reciprocals. Trig reciprocals in the calculator. Again, you don't need to worry about this because your calculator will actually, you know how you only have a sine, cosine, and tangent button on your calculator? The calculators that you have, you can type in alpha in secant, cosecant, cotangent, and it'll automatically calculate those out for you. So you don't need to worry about changing your calculator or worry about the reciprocal functions. I'll show you how to do that. All right, so here we go. Find the derivative. Sine of x times tangent of x. Well, look at that. What kind of rules would you apply to that? You know, you got a sine and you got a tangent there, two pieces. And we saw back in the day of the product rule how to deal with derivatives when you're trying to multiply things. And that's what we're going to do. We're going to apply the product rule. So here we go. Y prime, since they called it y, I'm going to call it y prime. The first times the derivative of the second. Sine of x stays sine of x. The derivative of tangent is secant squared. Where did I get that from? Up above with your rules. Plus the second, tangent, times the derivative of the first. Well, the derivative of sine is cosine. And then you look at it and you're like, well, can I make that any better? And this is a perfectly valid answer. And again, it depends on how a multiple choice answer would be shown on the test, right, on the AP exam. But here's another option, just I'll show you for fun. The sine of x times the secant squared x. I think about my reciprocals. This would be 1 over cosine squared. Well, that wouldn't do me any good here with this first term. It's going to stay, there's nothing to cancel out, in other words. And then I have a plus sign. Tangent, remember I just was talking about that up above. Tangent is sine over cosine times cosine. And you can see now why I did change that one versus not the first set of terms here, because now my cosines can cancel each other out. And so my final best answer for this question, in its most simplified form, is the sine of x secant squared x plus the sine of x.
We can write it tangent secant x plus sine x, right?
Tangent, say that.
Tangent secant x plus, well, tangent x secant x plus sine x.
Let me write this for a second. Tangent x secant x plus sine of x.
Yeah.
So you went ahead and did fun stuff with this, right? So you did sine over cosine squared. So sine over cosine is your tangent. 1 over cosine that you're left with is this. Yes, that would be an equivalent form. Yep. Do you see how these could be really interesting? Like there's so many different ways you could write them that are totally different from one another, but they're all equivalent. Cool. All right, so then it goes to number 2 down here. Number 2 is doing the same thing, but they find the derivative, but they want you to find the derivative when it's pi over 6. This one gets really lengthy. I'm going to come back to number 2 for a second. Let's go to 3 because 3 is a lot quicker. 3 is a calculator one. Do y'all have your calculators handy? Estimate the derivative with a calculator. Here's your function. Remember that this is the same thing as writing it this way, cosecant of 4x with the square on the outside. I think when you type that in your calculator, that's an easier way to put it in. At x equals 2. So we're grabbing calcs. I'm going to grab my calc. Here it is. All right. I want you to be able to see what I'm typing in there, but okay. Oh, seriously? It's out of batteries. What next? Hold on. See if I can steal batteries from another calculator. All right, technical difficulties. Hold on. Actually, while I'm doing this, why don't you see if you can do a quotient rule on number 3 while I'm fixing my battery issue. Quotient rule on number 2 while I'm changing batteries. It'll give us a head start when we go to do it. Okay. All right, pause. Let's go back to number 3. We're flip-flopping around here. So we want to find the derivative. Remember on the calculator how to find a derivative. So you go to your y equals. From your home menu, go to your y equals. And again, stop me if you don't remember how to do some of these things. But you're going to y equals, and you've got a couple of options. In the catalog, you'll find cosecant, cotangent, and secant. In the math menu, you'll find those things as well. I tend to prefer just to alpha it in. By the time I go and look searching for it, it's easier just for me to alpha it. So I'm going to put parentheses, start with parentheses, and I'm going to alpha a C, alpha an S, and alpha a C, CSC. And then I'm going to open a set of parentheses and put 4x in it. And I'm going to close that 4x parenthesis, and I'm going to close the cosecant parenthesis, and then I'm going to square that whole hot mess. And put it in enter. Now, if you're somebody that has physics right now, and you do everything in degrees, we do everything in radians, so make sure your mode is in radians. If you don't have a class where you've been changing it back and forth, then it's not going to matter. It should be in radians already for us. But back on the mode, you can have the mode button go in and change change it. All right, so one more time. The C. Okay. All right. So I started with my Y1, right? You're okay getting into Y. And then you're opening a set of parentheses. And then the alpha button is this white guy next to the Gatorade guy, alpha. C is the right-hand parenthesis. See the little white letters, A, B, C, D, E, starting with the equal sign on the left there? The C is that parenthesis. So you're going to alpha it, but each time you alpha, you have to hit, every time you need a letter, you have to alpha it. So it's alpha, right-hand parenthesis, alpha 3, that's your S. And then alpha, your right-hand parenthesis again, CSC. Open a set of parentheses after the CSC and put in a 4x. Close 2 parentheses and then square it. Okay. All right, sounds like you're all with me. All right, so we're going to take and graph it. So Gatorade F3. Check that out. Holy guacamole. Is your calculator freaking out like mine? You know what, Griffin? That's a great question. I don't know is the answer to your question, though. I'm not sure if putting the square, it should understand it. It's a standard notation, whether you put it in the way we put it in or whether you put the square after the trig function. Yeah, mine too. Oh. Are you in on Thursday, Hannah? Do you think you'll be in on Thursday? Okay, we should remind me on Thursday because I should be back Thursday too, and we can trade you in for a different one or something. Okay, so when it finally figures out all this craziness that we got going on, Griffin, did you put yours in with the square in the place you're talking about, or did you put it in the way that we put it in? Because I'd be interested to know if it turns out the same. All right, here we go. We're going to figure out what the derivative is. So I want to go to F5, the math menu. F5. I want to go down and find the derivative, so I'm hitting 6. I just press enter, and it says, where do you want the derivative at? And we say we want to know what it is at 2. And it tells you it is 1.202. Okay. Well, it'd be interesting if you have 2 seconds on your hand later, some time on your hands later, you can check it out the other way, see if it comes out to be the same thing. So, in other words, you can use your calculator. If you were using the old 83s, you would have to change this into something in terms of sine, cosine, or tangent, because that's the only thing that your calculator can do back in the days of the 83s. So that's what he's talking about here. Like, we would have had to have changed this into 1 over sine squared. we'd have to use the reciprocal relationships to be able to get it into the calculator. But your calculator is better than that, and you don't need to worry about it. Just, again, you can either find those trig functions, secant, cosecant, cotangent, in the math menu, in the catalog, or just alpha type them in. All right, so that takes care of number 3. Back to number 2. You should have started, hopefully started this guy, and this takes a lot of writing. So this one is going to be an f of x. We've taken f prime of x, derivative, bottom, times derivative of the top, minus the top, times the derivative of the bottom, ooh, secant x, tangent x, all over the bottom squared. You can't see me, hold on. How's that? That's better. All right. So then I'm going to see if I can clean this up any. I don't know that I can. I have a secant of x minus an x secant of x, tangent of x, over secant of x quantity squared.
Why can't you factor a secant out?
I just was looking at it and thinking the same thing. Like, I'm looking at, you get to this place when you have it cleaned up, and then you got to make some decisions. So
I tried and it doesn't work. The answer doesn't come out right.
if you factor out the secant,
I don't know if I did anything else wrong, but I factored out the secant on top, and then I canceled it with the square on the bottom.
that was the direction that I'm going to go with it as well. Can I make the... I'm looking at Jenna's question. Can you, my kids, can you see my screen better? I kind of moved things around a bit. Okay, thanks, Griffin. Couldn't you just make the equation x times cosine? Oh, back from the beginning. Oh, interesting thought, Jenna. She's saying right back here at the beginning, couldn't we have made that x times cosine of x? Jenna, did you do that by chance? Okay, let's see. Did you get an answer at the end? We'll see if we match, because that's pretty cool. That might be way easier than the way that we did, right? So let's see if we match Jenna. She took an easy route. We didn't. All right, but I'm going to go with what Sid said. Let's factor out a secant and we'll see what happens. So secant, if I factor it out, I get a 1 minus x tangent of x. And that now is over a secant squared x, which lets me then cancel out a secant with a secant. So I have 1 minus x tangent of x over just a secant of x. Now that's the way that I took it and the way that they did it when they did the video. So let's see. I need pi over 6. So I'm thinking pi over 6. I'm going to go into my margin here.
The video, he didn't simplify at all.
Oh, really? Huh.
Yeah, no.
That's weird. Okay. I know as I was watching it, I was just doing it. So I was kind of like following, but doing my own thing. Pi over 6, do you remember what the coordinate is? Well, you guys all have that crazy chart. Hopefully you've got the chart, right? I go back to the unit circle, and this guy is the square root of 3 over 2, 1/2. So if I can remember the coordinate, then I can answer all the questions that they want to know. So here we go. 1 minus x is pi over 6 times the tangent of pi over 6 all over the secant of pi over 6. Let me see if you can see me. Yeah, you can. All right, so I'm going to go into this next box, into my number 3 box, so I have some space here. So I've got 1 minus pi over 6. The tangent of pi over 6, well, tangent, you guys probably have it on if you've got that chart handy. Tangent is the y divided by the x. So I'm going to just, let me change colors. My y coordinate is 1/2. My x coordinate is the square root of 3 over 2. So if I do 1/2 divided by the square root of 3 over 2, it's 1/2 times 2 over the square root of 3, gives me 1 over the square root of 3. I rationalize, gives me the square root of 3 over over 3. Square root of 3 over 3. That's what this guy is. Square root of 3 over 3. Now, if you had your chart, if you're using the chart, you didn't need to do all that work. You have that number already. Whew, that's my numerator. Denominator is secant of pi over 6. Well, secant is reciprocal with cosine. Cosine is the x value. So I reciprocal that, and it is 2 square roots of 3. Well, it's 2 over the square root of 3. That's a hot mess, right? So now what I have, and I'm going to go horizontal because now I got complex fractions involved. So I've got 1 minus, I am the square root of pi square root of 3 over 18 divided by 2 over the square root of 3. And it's kind of, let's see what's going to happen with this thing. I have, are you okay if I turn this into one single fraction? So 1 is like 18 over 18. So it's going to be 18 minus pi square root of 3 all over 18 times, flipping this guy, square root of 3 over 2. Why is this totally different than what I got when I did it on? Oh, I know why. I rationalized this, which it shouldn't matter in the end. Let's see if we still get the same thing. You can't see. Miss Grace. Thank you. Maybe you guys can help me out here, but if I multiply this, I've got 18 square roots of 3 minus square root of 3 times the square root of 3 is 3, so minus 3 pi all over 36. Isn't the denominator I'm going to come back to that, Griffin. It is the same. The 2 square roots of 3 over 3 is rationalized, is when you rationalize it. I didn't rationalize, I just kept it the way it was. So if my x coordinate was the square root of 3 over 2, then for cosine, when I turned it into secant, it's 2 over the square root of 3. Now you can write that as 2 over the square root of 3, which is what I did in this problem, or you could rationalize it at this point and call it 2 square roots of 3 over 3. And I can show you the work for that in just a minute, because when I did it originally, I did it that way with 2 square roots of 3 over 3. This time around, that's why I'm in gray land right now, because I'm not doing it the way that I did it when I did it myself. But let's see if I match. We'll see how it goes. Okay, so 18 over 36 is like a 2, well, yeah, I guess I can do it that way. So 18 over 36 gives me a 2 on the bottom and a square root of 3 on the top. I'm going to keep these as separate fractions. So 18 square roots of 3 over 36 gives me the square root of 3 over 2. And 3 over 36 gives me just a pi on top. And 3 goes into 36 12 times. And that's what I'm saying the answer is. Does that sound right? Jenna, my girlfriend Jenna, When you got your final answer doing it with x cosine of x, what'd you get for an answer? Mine says the square root of 3 over 2 minus pi over 12. That was my final answer the way that I just showed it. Now let me show you, because this goes with what Griffin was talking about. You got that too? Wonderful. Okay, good. Very good. That's cool. And yours, Jenna, was yours way easier than the way that I did? Go girl. All right. All right, good. So let me show you. This is when I did it previously. And all of this, you don't need to watch all of this stuff, but we all match down to here. Like this is now 1 minus pi over 6 times the tangent of pi over 6 over the secant of pi over 6. All of our work matches up to this place. So here it is. I put the square root of 3 over 3 in for this. I did 2 square roots of 3 over 3 in the bottom. So I actually did it as the rationalized form. And then I wrote it as horizontally. That's this guy, right? Horizontally. And then I did the whole keep, change, flip thing and ended up with an answer that was 18 minus pi square roots of 3 over 12 square roots of 3. So another form, but the same answer. It's just an equivalent form. But ultimately, I like Jenna's idea best. So that's one of the things that he said back at the top of the page here, that sometimes simplifying, remember your simplifications for trig expressions, might be helpful. And she caught that one, so that was good. All right, we killed number 2. Are we ready to talk about something else? All right, here goes. Practice problems. So the first set, all these first guys are all talking about just find the derivative. So I'm looking at these and I'm thinking, I think number 3 is kind of interesting. Number 3 is an interesting one. Because when I looked at number 3, personally, I was like, oh, that's just like a 0. And it's really not. It's like it's theta. It's like an x value. So we don't tend to like using thetas in our stuff. So what I did was I said, let theta equal x. And if I tell Mr. AP that I'm going to do that, then you just do it. So that means that I can call this the sine of x over x. And for me, whatever, it just makes my brain happy to see x's rather than thetas in the problem. And it also helps with my derivative. It's easier for me to see what the derivative is going to be because it's what I'm used to. So if I'm looking at this particular function and I'm thinking derivatives, what rule would you apply to it? There's not really any trig simplifications like Jenna did on that last one for this guy. Anybody got an idea what I should do? What do I do? Thank you, Sir Griffin. Yes, I agree with you. All right. So, if I look at the quotient rule, here I go. X, bottom times derivative of the top, cosine of x minus sine of x times 1 divided by x squared, denominator squared. And then I just try to pretty it up a little bit. R prime, x cosine of x minus the sine of x all over x squared. Ain't much I can do with that guy. He just is. He is what he is. All right. That's it. That's pretty much that whole first set. So it's just applying maybe your quotient rule, maybe your product rule, like number 6 is a product rule. You've got a 5x and a secant of x. And these new rules for derivatives of these other trig functions. So let's try one from 7, 8, 9. Looking at my answers, and number 9 is the beastiest of those. So let's check 9 out. So if I'm looking at 9, it is find the derivative of the given x value. All right. So if I do that, x cotangent of x at x equals pi over 6. So it's a product rule. You've got two things being multiplied together. So we're going to go product ruling with this. First times the derivative of the second, which, by the way, I don't think I said this when we were doing this on the front page. One of the things he mentioned, if you didn't see the video, one of the things that he mentioned, I want you to just be able to see what I'm seeing. Gosh, these lamps. Hold on. Maybe that's better. So anything that starts with a C is negative. So that's helpful in your remembrance. But I know you've got your cards, but so if you've got a cosine, it's a negative sign. If you've got a cotangent, it's a negative cosecant squared. If you've got a cosecant, it's a negative cosecant cotangent. So all the ones that are C's are all going to be negative derivatives. So I did write that in the margin, and we didn't talk about that when we were doing our stuff. So, all right, cotangent. He's ugly. He is, actually no, he's negative cosecant squared. All right, first times the derivative of the second plus the second cotangent times the derivative of the first. Well, the derivative of x is a 1. And so if I make this better, it's a negative x cosecant squared x plus cotangent of x. There's nothing I can do to make that any better than it is. So now I'm going to plug in this pi over 6. So I want to know what f prime of pi over 6 is. So I have a negative. I have x, pi over 6. I have to remember the coordinate, but we just talked about this coordinate a minute ago. The coordinate is square root of 3 over 2, 1/2 for pi over 6. All right, so cosecant. Now let me think about this for a minute. Cosecant is reciprocal with sine. Sine is the y value. I need to reciprocal the y value. So I need to call that a 2 squared plus cotangent. Now cotangent is the x divided by the y instead of the y divided by the x, which is tangent. So cotangent is the x square root of 3 over 2 divided by the y 1/2. Let me do that work real quick. Times 2 over 1, cancel, cancel, I get a square root of 3. So this is plus a square root of 3. Okay, so let's do our work with this and see if we can simplify it any better. I have 4, 2 squared is 4. I have negative 4 pi over 6 plus a square root of 3. And I can reduce this just a bit more to make it a little bit prettier. 2 pi over 3 plus the square root of 3. And that's my final answer. That's the derivative at pi over 6. Now, they could have asked me for the equation of a tangent line or something like that, but they didn't. That was just, they stopped you there. Here's a yes or no question. Are you using your chart? I guess I need, for these things. Do you have the chart? Are you using the chart for these? Okay. Yeah, because remembering what I know that you're, okay, good. Okay, that's okay. Do you have one page? Do you have it paged there somewhere that you can grab it? Like not for right this second, but do you know where yours is? Okay, cool. Let me know if you need me to, I don't have mine. I've got to go search for mine if I were to look, but let me know if you need a copy of it, because I know that that's very helpful in the midst of this. All right, next ones are use your calculator. Let's try another one on your calculator. Pick me a number, 10, 11, or 12. Which one do you think will be hardest to put in your calc? 11. Okay, so you're going to go to your y equals. Let me put my lamp back on here. Okay, so you're going to clear out your y equals. We're looking at number 11. And I actually would look at this guy as being the same thing. See how the 2's on the bottom? That's like a 1/2. Instead of it kind of written that way, it's like a 1/2. And I know you're probably in the glare of my light here. Maybe I'll write it over here. 1/2. That doesn't help any either. Anyway, 1/2 and then cotangent of x squared. All right, let's see if we can type it in here. 1/2. 1/2 is the same thing as 0.5. You could do that. So I think that's what I'll do as I'm putting it in the calc. So do 0.5. And then I'm going to open a set of parentheses, and I want cotangent. So I'm going to alpha. So I'm alpha, right parenthesis. That's my C. O is the subtraction sign. So alpha subtraction. T. Oh, T is up here with, see how it's X, Y, Z, T? There's T. T is right here in your X, Y, Z stuff. T. Open a set of parentheses. Put an x squared in it. You don't need to put you can do the square on the outside or the inside. I'm going to just keep it on the inside. X squared. Close those parentheses. Close the cotangent parentheses, and I think you're good. So 0.5 parentheses, COT, parenthesis, open, x squared, and then close two parentheses, and that should give you what you need. T is, let me show you T. See this line? You have X, Y, Z. There's a T. Isn't that weird?
Wait, I'm sorry. What did you say at the end? You lost me at the very end.
So what do you have in there right now, Sid?
I have 0.5 times cotangent x squared.
You need two sets of parentheses to close it off. So you need one set of parentheses for the x squared, and then you need another one for the cotangent. So it needs two sets of parentheses at that end.
Okay, got you.
Okay, and then it should show up on your screen like it should be. Now I'm going to graph it so we can get to that derivative. Now this one looks like a heartbeat or something, I don't know. All right, so when it's done being busy, you're going to go to your F5 and you're going to go to 6, find the derivative, press enter. You want to know the derivative at -1. And it tells you you've got 1.4123. And that's it. So those are pretty quick once you see how to do them in the calculator. Everybody good with those? We be flipping. I'm picking the harder ones, or the ones as I looked that require a little more work. So 14 is the next one that would be a little more work. So 14, the question says, find the equation of both the normal line and the tangent line. Remember those guys, right? Your normal line is perpendicular to the tangent line, so really you just find the tangent line first, and then negative reciprocal the slope to be able to get to the normal line. So it's just like asking you, what's the equation of the tangent line first? Now, they just gave you tangent of x. They were kind of nice in the midst of this. So when you find the derivative to find the slope, your derivative is secant squared. Well, you want to know what it is at pi over 3. So I want to know what's the secant squared at pi over 3. Actually, I'm going to write it with the square on the outside. It just makes more sense algebraically to me. So sine of pi over 3, and that whole thing is being squared. Well, I've got to remember what the coordinate is if I'm thinking the unit circle, because I don't have the chart in front of me. So I know that at pi over 3, the coordinate is 1/2 the square root of 3 over 2. If we were in my room, you could see it on the wall, but we're taking that out of Leonard's brain, trusting that it's true. I think it is. Okay, secant of pi over 3. Secant is reciprocal with cosine. Cosine is the x value. If I were to reciprocal the x value, it's a 2. And I want to square it, so I have a slope that's 4. That's actually really sweet in the midst of all this, right? We don't normally get nice, pretty things like that. So there's my slope, but I also then need a point. And I know the x value for my point is pi over 3. But I do not know the y value. So I need to go on a journey to find that y value. The y value is, go back to the original, the tangent of pi over 3. Now those of you with the handy dandy chart, you're jumping for joy because you don't have to do this extra math. But for those of us without the chart, if we know the coordinate, it's y divided by x. So it's a square root of 3 over 2 divided by 1/2. Or the square root of 3 over 2 times 2 over 1, which 2's cancel, gives me the square root of 3. And so then I'm ready to put the line together, right? I've got all the things I need. Let's go tangenting first. I do y minus the square root of 3 equals m, which is 4, times x minus pi over 3. And then the normal line, all I need to do is change my slope from 4 to its negative reciprocal, which would be negative 1/4. So the rest of this stays exactly the same. I get a negative 1/4 as my slope. That's the only change. I'm sitting in front of a window and I'm wondering if that is causing my screen to be, maybe that makes it better.
Miss Butter.
Okay.
Miss Butter.
Yeah.
I have a question about 13.
Yeah.
I'm doing it.
Yeah.
If the slope is 0.
Yeah, it does come out to be 0. So let's talk 13 just for a second, since now you guys can work your way to this, but the slope does come out to be 0. Now think about that for a minute. If the slope is 0, what kind of line is that? Slope is 0. This is 0 fun, Mr. Slope Dude says. Anybody? If the slope is 0, what kind of line is it?
A horizontal line.
Yes, thank you. So if it's a horizontal line, any horizontal line, what's its equation going to be? It's got to be, think about it, it's going through the y-axis. It's got to be a y equals. So really, the answer to this question is whatever the y is for your point. That's going to be what your tangent line is. Does that make sense before I talk about the normal line?
Yeah.
Okay, so y equals whatever your y coordinate is for a horizontal line. Now, if I have a slope that's 0 and I reciprocal it, say it's like 0 over 1. If I reciprocal that, my perpendicular slope is going to be 1 over 0. And you say to me, I don't think so, right? You can't have a 0 denominator. This would be undefined. And if I have an undefined slope, now what kind of line do I have?
Straight up and down.
Vertical, right? That's going to be x equals whatever the x coordinate is. So, interesting. It kind of takes you on a little bit of an algebra journey back from the day. Number 13 does. All right, we're going to finish this section looking at numbers 15, 16, which is actually the end of the stuff. These are your 2 test prep questions. So it doesn't matter which one we look at. Let's go for 16. So I'm looking at this and they say evaluate the limit. And you look at that and you're like, what on earth? But hopefully there are some bells ringing for you. Well, gee, I think I've seen that before somewhere. The limit is h approaches 0 of f of x plus h minus f of x all over h. Remember that guy? That's your definition of a derivative based off of limits. So we're kind of thinking of this. You don't necessarily have to write this. I'm just going to write it so you can see it. F of x plus h minus f of x all over h. In other words, it wants me to find the derivative. Evaluating that limit is the same thing as finding that particular derivative. Now, if I'm finding this derivative, that means that I've got to figure out what the function is, right? Where the heck is the function in the midst of all this stuff? So the reason I wrote it out this way is so you can see where the function is. It's this second piece. It's this piece right here. So I want to know what the derivative, f prime at pi over 6 for the secant of x. That's what this is saying to me. Find the derivative of the secant at pi over 6. Find the derivative of the secant at pi over 6. You kind of have to read and decipher where the information is in the midst of that limit. So if I think of secant, secant's derivative, f prime, I'm just going to keep it as an x first of all, is secant of x tangent of x. Well, I want to know what it is at pi over 6. Secant of pi over 6 times tangent of pi over 6. And then I can, let me move this so you can see it better. Then I can evaluate that. Now we've been doing pi over 6 a lot today. Pi over 6's coordinate again is square root of 3 over 2, 1/2. Those of you with the chart, go for it. So the secant of pi over 6, secant is reciprocal with cosine. Cosine is the square root of 3 over 2. So this guy's going to be, I'm going to just keep it as 2 over the square root of 3. We may need to rationalize in the end, but let's just see what happens. Tangent, tangent is y divided by x. 1/2 divided by the square root of 3 over 2. This one's going to be 1/2 times 2 over the square root of 3. Gives me 1 over the square root of 3. I'm going to leave it that way as well for now. And so when I multiply these together, 2 times 1 is 2. Yay, my square roots of 3s are good. I didn't have to rationalize. They become just a 3, and my answer is 2/3. So the whole idea of that was trying to figure out what are they really asking me to do. It's not really a hard process. It's just where the heck is the function that I'm supposed to take a derivative of. And so there it was, hiding at the end.